All right, so we are on question 29. All right, so we're gonna pick up with similarity where we left off last video. Okay, so let's read it. So the ratio of similarity of triangle BOY to GRL is 1 to 2. Okay, so we have triangle BOY. Sorry, excuse me, bless me. To GRL. GRL is 1 to 2. If BO is equal to x plus 3 and GR is equal to 3x minus 1, then the length of GR is what? Okay, so we are finding the length of GR. Now the ratio is 1 to 2. So we're going to set up a proportion. So 1 over 2 is going to equal, so this is kind of like our scale factor, if you will. So this is equal to x plus 3 over 3x minus 1. Okay. Now to solve for x, cross multiply. So we have 3x minus 1 is equal to 2 times x plus 3. 3x minus 1 is equal to 2x plus 6. Okay. So minus 2x plus 1, so x is equal to 7. Now, do not pick 7, because let's go back and read the question. The length of GR is, so we have to plug our x into this expression. So 3 times 7 minus 1. 21 minus 1 is 20. So our answer is 20. Okay. So 30, line L is mapped onto line M by dilation centered at the origin with a scale factor of 2. The equation of line L is 3x minus y is equal to 4. We want to determine and state an equation for line M. Okay, so first of all, line dilation, only thing that changes in a line dilation is the y-intercept. Okay. So first of all, we need to figure out what that y-intercept is. So let's solve for y. So our equation is 3x minus 4 is equal to y. Okay. Now our scale factor is 2, so we're taking 2 and multiplying it by negative 4. So this is line L. So line M is equal to 3x minus 8 is equal to y. Okay. So this is our answer. Line M is this equation, has this equation. Okay. So let's take a look at 31. So the aspect ratio. So aspect ratio is just the ratio of width to height. So of this, on like the same figure, on the same triangle or rectangle or whatever. I mean, that's all aspect ratio is. Of a rectangular flat screen television is 16 to 9. So to width to height, so 16 to 9. The length of the diagonal of a screen is the television screen size. We want to determine and state to the nearest inch the screen size of this flat screen with a screen height of 20.6 inches. Okay, so we have to be careful. This is the ratio. Okay, so the ratio of width to height is 16 to 9. Now the height is 20.6 inches. Okay, so we want to find the diagonal. Now here's the thing, that we can't find the diagonal using Pythagorean theorem unless we have to know both the width and the height for that. Okay, so we're going to solve a proportion to find the width. All right, so we're going to do 16 over 9 is equal to x over 20.6. Okay, so 16 times 20.6 is 329.6 is equal to 9x. Okay, we're going to divide both sides by 9. So x is 36.62 repeating. Okay, so this is the width and this is the height. So now to solve for the diagonal, the length of the screen size of the television, we need to use Pythagorean theorem. Okay, so we're gonna plug this in. Plus 20.6 squared is equal to c squared. Okay, so let's do second answer squared plus 20.6 squared. And we're just going to take the square root. Oh, geez. Okay, wait, let's write this down. So 17.65.54716 is equal to c squared. We're going to take the square root of our answer, so we get c to be 42.018414454. Okay, so to the nearest inch, our television screen is 42 inches, so the screen size is 42 inches. Okay. All right, on we go to the next one. All right, so given the theorem, the sum of the measures of the interior angles of a triangle is 180 degrees. We want to complete the proof for this theorem. Okay. So this is a little weird. We're not going to be using like our normal proof rules. We're going to kind of, this is a little funkier, or not funkier, just kind of different. Maybe more a little straightforward than we're used to. Okay, we're still going to write down our given, so still same structure. So our given is triangle ABC. That's a given. Okay, so let's take a look at what we have. So we have triangle ABC, we have angles 1, 2, and 3, and we want to prove that they add up to 180 degrees. Now, this is a fact that we know, right? All angles in a triangle add up to 180 degrees, so we have to prove that, okay? Now, as you can see, there is a dotted line that is drawn through point C, okay? Now, these look parallel, okay? But we can't just kind of, well, we can actually. Okay, wait. All right, so that's the first step we need to take, is to say that line DCE is parallel to AB. Okay, so we're gonna say it like this though. Through point C, DCE, or draw DCE parallel to AB. Now, as you can see, this is a dotted line. This isn't like a real line, if you will. Okay, so that's why we're kind of drawing it. Okay, and you'll see in a minute. Now, our reasoning for this is to a given line, there is only one parallel line that runs, that can be drawn through a given point not on the line. right? Now, this is kind of a fact about lines. We, in like our first unit when we started talking about geometry, this was just, we kind of went through a lesson about lines. This is just kind of one of those facts. This is kind of one of those random things about lines that is true. Okay. So now we're going to say that this angle and this angle and these two angles are equal because they are alternate interior angles. Okay, so angle 1 is congruent, or excuse me, we're going to say the measure of angle 1 is equal, because do you see how, guys, how they use the measure symbol instead of like the congruence? So if they have that here, then in here you should have that as well. Okay, so the measure of angle 1 is equal to the measure of angle ACD, and the measure of angle 3 is equal to the measure of angle BCE, because if two lines are parallel, then alternate interior angles are congruent. Okay. Now here's the thing. These three angles right here all right, so sorry, I got interrupted, but let's go back. So I think I was talking about how these three angles add up to 180 degrees. So the measure of angle ACD plus the measure of angle 2 plus the measure of angle BCE is equal to 180 degrees. And this is because the sum of the angles on one side of a line is equal to 180. Now you could also say, because these are, well, I don't know, because there's three angles. So the problem is, so if there were just two angles, you could call these a linear pair, but I'm not sure what you call it when there's three angles, but the measures, the sum of the angles on one side of a line is equal to 180. So all of these angles are supplementary, they add up to 180, okay? That's just whatever. That's, again, just another fact. Now, we need this. Now, the measure of angle 1, these are equal, like we said in here, and these are equal, okay? So we're gonna take these and we're gonna substitute it in here. So I'm just gonna write it up here, just because I ran out of room. All right, so the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 is equal to 180, okay? And this is by substitution. Okay. So it's a little different of a proof, but we just wanted you to see it. So you know, like, if you get something like this is kind of the more process of what you would need to do versus kind of our usual proofs that we usually see, okay? All right, I'm gonna take a drink of water and then we can go on to 33. All right, so Kathy wants to determine the height of the flagpole shown in the diagram below. She uses a survey instrument to measure the angle of elevation to the top of the flagpole and determines it to be 34.9 degrees. She walks 8 meters closer and determines the new measure of the angle of elevation to be 52.8. At each measurement, the survey instrument is 1.7 meters above the ground. Now we want to determine and state to the nearest tenth of a meter the height of the flagpole. Okay, I'm going to highlight these triangles just to make it a little easier to see. Okay, so we want to find this. We're gonna call this X, the height of the flagpole. Now, here's the thing. We can't fully use SOHCAHTOA because we don't really know this full side. So we're gonna have to take a few steps to find, you know, some things that we could use to find the height of the flagpole, okay? Now, this question, we are gonna use law of sines because this triangle is a non-right triangle, okay? So we can use law of sines to find one of these two sides of the triangle. So we can use, so we can either find this one or we could find that side. I'm personally gonna find this side, okay? And then I'm gonna do SOHCAHTOA on this triangle, but I mean, you could also find this side and use SOHCAHTOA on the bigger triangle, but that's completely up to you. But I'm gonna find this side right here. Oh my gosh. I'm gonna find this side. Okay. Now we need a couple different angles to use law of sines. So let's find these other two angles in this triangle. Now these two angles are supplementary, so they add up to 180. So 180 minus 52.8 is 127.2. Now all these two angles and this angle add up to 180, so I'm going to do 180 minus 127.2 plus 34.9 is equal to 17.9. Okay. So now remember, law of sines is sine of A over A. Side A is equal to sine of B over B. Okay. So we can use our crisscross thingy. So remember, I'm solving for this side. I'm going to call it side B. Okay, so I'm going to use this side right here. So now the angle across from that side is 17.9, so sine of 17.9 is equal to the sine of 34.9 over B. Okay, so I'm going to first solve for B. We're going to cross multiply. Okay, we're going to divide by the sine of 17.9. Okay, so all right, so 8 times the sine of 34.9 over the sine of 17.9. So B is equal to 14.89203,981. Okay, so that is this side. So I'm going to redraw this triangle. We're going to do this work down here. This is 52.8. This is 14.89203,981. We're just gonna leave it all. Now, one thing I forgot to mention when the start of the problem, this triangle is kind of elevated 1.7 meters. So the height of the flagpole is X plus 1.7, okay? So once we find X, we have to add 1.7 to it to find the entire length. okay? So let's find x. So here's that triangle we're using. So x is the opposite and the hypotenuse, so we're doing the sine of 52.8 is equal to x over 14.8920391. Cross multiply, so 14 point blah 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 times the sine of 52.8 is equal to x. Okay, so this times the sine of 52.8, so 11.86195525, and remember we have to add 1.7. So x is equal to 13, oh wait, no. We already added 1.7 to it. So this right here, this right here, 13.56195525 is the height of the flagpole, okay? So we have to determine to the nearest tenth of a meter. So tenth, we round up, so 13.6 in meters is the height of the flagpole. Woo! All right, so we have a few more questions left, and then there's a couple things that I want to go over with you after that, so just hang tight. These questions aren't too bad. Not as bad as this one. All right, so we're going to talk about the exterior angle theorem. Now, I did briefly talk about this, but let's talk about it again. So we're just going to call this angle 1, angle 2, and angle 3 just for the sake of being simple. Now, the exterior angle theorem says that if the measure of angle 1 plus the measure of angle 2, I don't know why I said if, the measure, well, it is a fact that the measure of angle 1 plus the measure of angle 2 is equal to the measure of angle 3. Okay? So when you guys get questions on the exterior angle theorem and you get a question like this, all you're doing is you're taking these two angles, you're adding them and setting it equal to the exterior angle. Okay? So let's do that. So let's do x plus 40 plus 3x plus 10 is equal to 6x. Okay? So let's solve for x. So we have 4x plus 50 is equal to 6x minus 2x, so 50 is equal to 4x. I don't know why I just subtracted 2x. This should be 4x. Oh my Jesus. Okay. So 50 is equal to 2x. So x is equal to 25. Now, let's read the question. What is the measure of angle CAB? So CAB is this angle right here, so x plus 40. So we need to take x and add 40 to it. So 25 plus 40 is equal to 65, so the measure of angle CAB is equal to 65 degrees. All right, onward we go. So let's go to the next question. In the diagram of triangle PQR shown below, PR is extended to S, the measure of angle P is equal to 110, the measure of angle Q is 4x, and the measure of angle QRS is equal to x squared plus 5x. Okay, so you want to find the measure of angle Q, this one. Okay, so same thing. These two angles added together is equal to this angle. So 4x plus 110 is equal to x squared plus 5x. Okay, now this is a quadratic. Okay, so the first thing we need to do to be able to solve this equation is get it set equal to 0. Okay, so let's go to our table here. So x squared plus x minus 110. We go to our second table. Oh, am I gonna have to go through this? So 1x is negative 11. And then we might be going in the wrong direction. Possibly. There's usually one positive, so there will be a one positive and one negative for this. So let's see if we can find a positive. Oh, here we go. So x is equal to 10. Okay. Now, since that is negative, we cannot use that. So we need to take our x and we need to plug it in our expression for q. So q is equal to 4x. So we need to take our 10 and multiply by 4. So we need to do 4 times 10 is equal to 40. So the measure of angle Q is equal to 40. Cool. All right, next question. So in triangle ABC, so we have triangle ABC. If the measure of angle CAB is 2x, so this is 2x, measure of ACB is x plus 30, so this is x plus 30. If AB is extended through point B to point D, and if CBD is 5x minus 50, what is the value of x? Okay, so same thing, this is an exterior angle. So this angle plus this angle is equal to this whole angle. All right, so x plus 30 plus 2x is equal to 5x minus 50. Okay, so let's solve our equation for x. Okay, so now the question actually asks us for the value of x, so x is equal to 40. So that is our answer. Okay. All right, 2 more, let's go. All right, so number 37. In the diagram below, point B is the incenter of triangle FEC and EBR and CBD and FB are drawn. Okay, now really quickly, the incenter is where the angle bisectors intersect. Okay, so if FEC is 84 and ECF is 28, ECF, this is 28. So we want to determine and state the measure of angle BRC. Okay, now here we have a triangle. So if you can notice this triangle right here. Okay, so all of 3 angles, so this angle plus this angle plus this angle is equal to 180. Okay, so all we need to do is find the measure of this angle. Now EBR is an angle bisector because it goes through the incenter. Okay, so half of 84 is 42. So 42 plus 28 minus 180 gives us the measure that we want, the angle, measure of the angle that we want. So 42 plus 28, then 180 minus 70 is equal to 110. Okay, so the measure of angle BRC is equal to 110. All right, so last question. So before I go over this question, I want to quickly talk about these definitions. Now, a few of them I talked about in class, but a couple of them I didn't, and I just want to go over that really quickly. Okay, now the centroid, we have talked about the centroid before, which is the intersection of the medians. The orthocenter is where the altitudes intersect, the circumcenter is where the perpendicular bisectors intersect, and the incenter, like we just talked about in that previous question, is where the angle bisectors intersect. Okay? So now, so for a triangle, which 2 points of concurrence could be located outside the triangle? Okay, so which 2 of these intersection points could be located outside the triangle? Now, this is something we just need to know, that the circumcenter, circumcenter is where the perpendicular bisectors intersect, and the orthocenter, where the altitudes intersect, they can be located outside of the triangle, kind of depending on what type of triangle it is, okay? So usually, most likely, if you have an obtuse triangle, the altitudes are going to meet outside of the triangle. And why can I? So remember, altitudes are perpendicular, drawn perpendicular, and then the circumcenter, so that's the orthocenter, this is the orthocenter, and the circumcenter is where the perpendicular bisectors intersect, so same thing. Okay, so they can be both located outside the circle. Alright, so before I end the video, there's a couple questions I want to go over. One thing that I didn't go over with you and that I kind of wanted to is similarity proofs. Specifically, the product of the means is equal to the product of the extremes type of proof, similarity proof. Okay. So if we have, I'm just going to do like a quick little mini example. Okay. So we are given that NP is parallel to QR, okay? So this is the kind of diagram that we have drawn here. So we have NP and QR, and this is point M, okay? Now, whenever you see prove MN times MR is equal to MQ times NP, you know, or you should know, that this is a similarity proof. Okay, now this is always like the last thing that we have, right? What you're trying to prove is always our last reason. So statements and then reasons, okay? So this is our last step. So MN times MR is equal to MQ times MP. So our reasoning for this is the product of the extremes is equal to the product, or the product of the means, sorry. The product of the means is equal to the product of the extremes. Now, before we can even start in somewhere, we have to figure out what types of triangles we have to prove similar. But before that, remember our step before this is our ratio thing. Okay, so if you remember my little trick here, so 1, 2, 3, 4, so 4 over 2 is equal to 1 over 3. So MN, and this is MR goes here, MQ, and MP. Okay. So now from this, we can figure out what type of triangles we need to prove. So we have NP over MR, and we have MQ over MN. Okay, so it looks like we have to prove triangles MNP similar to triangle MQR. Okay. Now our reasoning for this, we'll come back to that reasoning, but let's go through this proof and let's see what we got here. Okay, so we are given NP is parallel to QR. So this is our given. Now, our three reasons for similarity are angle, angle, side, and side, and side, side, side. Now, these are rare and most of the time never used. So always try to go for the angle, angle. Okay, now angle M is congruent to angle M. So I'm going to call this angle 1, right, because of reflexive. Okay, number 3. Now, since these two lines are parallel, we have corresponding angles. So we can say that angle 2 is congruent to angle 3. So angle 2 is congruent to angle 3, because if two lines are parallel, then corresponding angles are congruent. Okay, now we have an angle and we have an angle. So by angle, angle similarity, these two triangles are congruent. Now our reasoning for this, remember, is CSSTP, corresponding sides of similar triangles are proportional. Okay, and now this is our last step, right? The product of the means is equal to the product of the extremes. Okay, so I just wanted to quickly go over that because I feel like we haven't talked about that in a while, and I just want to make sure we kind of refamiliarize ourselves with it on the off chance that we actually you guys get something like that on the Regents. Okay, so for the most part, this is the last video. I may post another video of another like random type of crazy question on this day, so please, if I do have a part 2 on Taste Friday, so you guys are going to watch this on Friday, if I do post something, please go watch it. Okay, all right, so good work, study, get some rest before the Regents, and hopefully I'll see you guys on Monday for the review, but if not, I will definitely see you Tuesday morning. All right.